Hi there, welcome back to this channel. In this video, we are going to be talking about unit vectors. Now, what are unit vectors? Unit vectors are vectors that have exactly one unit. They have exactly one unit, and they point in a particular direction. So we already know that vectors have magnitude and direction. So unit vectors are a special way of viewing three-dimensional the three-dimensional space, and that is why they use magnitudes. They use letters that basically represent the three dimensions that we have. So you will see things like X, yeah, you see letters like I, J, K, and these letters correspond to the three directions X, Y, and Z. Do you understand? So they correspond to the X, Y, and Z, and that is a way of just saying that you have the X, the Y, and the Z plane. So this Z plane is basically going into the board, and or you could think of it like coming out of the board in this direction, then this other guy is coming out of the board in this direction, and then this one is straight. So these are Y-axis, Z-axis, and our X-axis. All right, so that's basically what it portends like in the 3D space. But basically, we want to talk about how to treat them, to deal with them in terms of mathematical approaches. So the first thing is we want to learn um, uh, how they are denoted. Then we'll learn about the addition, subtraction, multiplication, and division. I know. So now we know that, okay, we don't do division rather. We know that. So when you have vector, for example, force is a vector, momentum is a force is a vector, moment is a vector. So if I say the vector force, F, for example, is represented in P sub xi plus P sub yj, P sub yj plus maybe minus P sub zk. This means that in x direction, in y direction, and in z direction. So this just denotes a magnitude in x direction, a magnitude in y direction, and a particular um, other one in the z axis. All right. So now, how do we work with them? How do we work with them? So the first thing we should learn is, this is how we denote them. The first thing we should learn is how to find the modulus or magnitude of a unit vector. The magnitude of a unit vector. So for example, you are told to find the magnitude of this vector, you would say the vector f. You take the modulus this way, it becomes the square root of the one on the x-axis, that will be px squared, plus in this case, p sub y squared, then minus p. Now you're adding everything, is that okay? Then minus pz squared also. So the magnitude of this will be the magnitude of our vector. So for example, if I said a vector A is denoted by 3i, or is represented rather by 3i minus 4j plus 2k. So what you have is the find, and I say find the magnitude, find a modulus. All right. So what you do is you say a modulus will be equal to the square root. So the square root of 3 squared plus minus 4 squared plus 2 squared, right? And that is basically 3 squared is 9 plus minus 4 is 16 plus 2 squared is 4. This plus this is 25 plus that will be the square root of 29 essentially, right? And that will be the modulus of A, or the magnitude of A. Then, because no unit is specified, we add unit. You understand? All right, so if it's for a force, it would be Newton, root 29 newtons. So that is how to find the magnitude of a unit vector. Now, how do we now have, what if we now have more than one vector and we needed to add them? So let's go into the addition of unit vectors. Addition. Vector addition. So now to do vectorial addition, it's very simple. Now all you have to do is that add entities that are similar together. So for example, if you have pxi, now for example, I have my force to be px sub I, p sub xi plus p sub yj minus p sub zk, and I had d to be a sub xi plus a sub yj plus a sub zk. Now I told you to find vector f plus vector d. All right. Now if you wanted to add this, albeit you can't add, and if this was distance and force, I mean you're not going to be adding this, but I'm just giving an example. So if you wanted to add this will become p sub x plus a sub x, because they both have I in common, so they both point in the I direction. So then plus p sub y plus a sub y that both point in the j direction, and plus minus p sub z plus a sub z that both point in the k direction. That becomes a sub z minus p sub z. Now, what I'm saying essentially is that add entities that are alike. Do you understand? So for example, if my vector A was given as this, so another example, and vector B is given as 5i minus 3j minus k. So for example, now what would be find, the question now says find vector A plus vector B. All right. Now you can see the vectors written as a cap also. All right. So how do you add this? So since A is this 3i minus 4j plus 2k, and B is this 5i minus 3j, you simply say A plus B, vector A plus B would be equal to 5i or 3i, that will be 3 plus 5 i's, because they both carry I, then plus, or let's write it out in full first. So this would become 3i, write it out first, 3i minus 4j plus 2k, then plus 5i minus 3j minus k. So then the one that I like are this guy, and this guy. So what do? You have 3 plus 5i, or 3i plus 5i, then plus minus 4 plus minus 4 minus 3 or j, then plus 2 minus 1. 2 plus minus 1. Do you understand? Because you're adding them 2 plus minus 1. So this is minus 4 plus minus 3. Right. So both of these become 2 plus minus 1k. So we'd have this plus this 8i, follow me, plus this minus this, that will be minus 4 plus minus this, that's minus 7. Minus 7j plus 2 plus minus 1, that's 2 minus 1, which is 1k. All right, so what we have here is 8i minus 7j plus k, and this is the value of a vector plus b vector. But how do we find the magnitude of that? So the magnitude of a vector plus b vector will be equal to 8 squared plus minus 7 squared plus 1 squared. And that gives us the square root of 8 squared is 64 plus 49 and plus 1. And that becomes 50 plus 50, 100, 114, 114. All right, now you can simplify that with your calculator, but this will be the magnitude in the particular or specified unit. All right, so that is how to find the addition of vectors. The addition of vectors. Now, what if we want to what if we want to subtract vectors? Vector subtraction, how do we do it? You see, both addition and subtraction follow the same process. Both addition and subtraction, they follow the same process, so that we have, I said, subtraction of vectors. Now let's say, given the same vectors, and you were told to find a vector minus b vector. How do you do that? You basically say that it will be 3i minus 4j plus 2k. Now minus, you open the brackets, then 5i minus 3j minus k. This is what we have. And then you now re-express this, and you have 3i minus 4j plus 2k. This one is unchanged. Then minus 5i plus 3j plus k. Is that okay? Then what you have is from here 3i minus 3i. You now begin what we did the other time, more like collection of like terms. So this will become 3i minus 3 minus 5i, then, or you can just bring them together this way, 3i minus 5i minus 4j plus 3j, then plus 2k plus k. Does that make sense? Right, rather than even opening brackets and all that. So you can just do this, and you have this minus this is what? Minus 2i. Then minus 4j plus this is minus j, and you have plus 3k. And this will be the value of a vector minus b vector. And if you are told to find the magnitude of that would be equal to the square root of minus 2 squared minus plus minus 1 squared and plus 3 squared. And this becomes the square root of 4 plus 1 plus 9. And this is 6 plus this root 15, and that units. All right, and that will be the value of this vector, value of this vector. Now, let's go to the subtraction of vectors, the multiplication of vectors. Now, multiplication of unit vectors. The board is quite hard to clean because it's the Harmattan season. Multiplication of unit vectors. Now, the first thing you should know is that there are two types of multiplication of unit vectors. We have what we call the scalar multiplication. The scalar multiplication. I'm going to drop I'm going to do a video on, or I said make a video rather, on the use of scalar multiplication and the use of vector multiplication, because it's going to be a short, is that okay? But here, let's first learn how to do the scalar multiplication. Now, if I had my vector A, first know that scalar multiplication is also called dot product. Scalar multiplication is also called what? The dot product. That is why if I said to find the dot product of these my two vectors, it would be A dot B. All right, and it's given by the formula A, the modulus of B, or the magnitude of A, times the magnitude of B cos phi or cos theta, or any angle between them. Is that okay? The angle between them. The magnitude of A by the magnitude of B cos the angle between them. All right. This is the formula. Now, there is more to these maths because we have to draw the angle, what's it called, the triangle, and then begin to analyze. But just know this. Just know this. Nobody will ask you the derivation. Do you understand? But just know this. A dot B is this times B. I mean, modulo of this times modulo of this cos phi. The difference between this and the second one is just this sign. You get this cos. It's going to be sine for the other one. All right, now, first, how do we find modulus of this? We've done that here. So we find the modulus. Now, the second way of finding A dot B, or going about A dot B, is what we really call the vector, the dot product. And what we do here is we multiply terms that are alike. But it doesn't mean that when you want to, generally if I wanted to open this bracket, if I had A, my A was given as 3i minus 4j plus 2k, and B is given as 5i minus 3j minus k, for example. Now, if I want to do A dot B here, now you would expect that I will open this times this time, and this times this, and this times this. Now, you'll be correct to do that. But it will be a waste of time because I dot j gives 0, and I'll tell you why. Now you see, I dot I gives 1 because because they are in the same direction. I and I represent x direction, right? So because they are in the same direction, the angle between them is 0. And cosine of 0 is 1. Is that clear? All right. And if you remember, we said that the other one, z plane, y plane, and x plane, the angle between them is perfect 90 degrees. Perfect 90 degrees. Perfect 90 degrees. Do you understand? So perfect 90 degrees between all of them, meaning that the angle between I and J will be 90 degrees. And cos 90 degrees is what? 0. So that is why if you do I dot I, you will get 1. So if you do j dot j, because they are in the same direction, angle between them is 0, cos 0, 1. If you do I dot k dot k, you will get 1. But if you do I dot j, because the angle between them is perfect 90 degrees, you have what? 0, cos 0, cos of 90 is 0. And you have I dot j is I dot k is 0, and j dot k is also what? 0. So that is why it is needless to begin to do 3 times I and 3 times z, 3 times k. Do you understand me? All right. I just proved to you why you get, so this is the principle. This is the principle here. I dot I gives 1. So because it gives 1, we necessarily just say this times this. Do you understand? So what we have here, A dot B will now become 3 times this will give us what? 15. Do you understand that? Because 3I dot 3I is simple. 3I times 3I. I times I, 1. 3 times 3, 9. Do you understand? 9 times 1, 9. Do you understand? So it doesn't change. I disappears. That's what I want to say. I wanted to say. I disappears. All right. And if you do this times this, you get 0. This times this 0. So you just move on to the next. If you do this times this, another 0. So you just say minus 4 times minus 3 will give you what? Plus 12. Then here, plus 2 times minus 1 will give you what? Plus 2 times minus 1 will give you minus 2. And this will give you altogether 15 plus 12, 27 minus 2, that's 25. So you have 25 units. So that is the dot product of A and B. This is A dot B. Right. So if you are told to now find the angle, you can now say it means that phi here will be equal to A dot B over the modulus of both vectors. Do you understand me? I mean the cos inverse, because there is cos there. Okay, so this will say will be cos phi. So that phi will be equal to the cos inverse of A dot B over the product of the moduli. Do you understand? All right. So that is how to find dot product. Now the second type of multiplication is the one we call the vector product. Vector product, or vector multiplication rather, or cross product. Vector multiplication or cross product. Now, how do you do vector multiplication? How do you do vector multiplication? Now, it is very simple. We're still going to use the same vectors. We said if A was 3I minus 4J plus 2K, and B was 5I minus 3J minus K. Now, if you are told to solve for A cross B, first know that the formula is the modulus of A times the modulus of B, now this time sine theta or sine phi. Do you understand? That is the angle between them. I've told you that there is more math to this, but we call it cross product, and it is the modulus of this, and the sine is, the trig function between them, sine of the angle, sine of the angle. All right. So we already know how to find the modulus still. So how do we find, which other way can we use to find the cross product? Also bear in mind that A cross B is equal to, now we can use the determinant method of matrices to find the vector product. So if this was were our vectors, so what you would do is you arrange them in matrix method. So what you have is we'll have the matrix grid here, and then we have vectors I, j, and k here. Is that okay? So we write only their coefficients. So we have 3, -4, and 2, and then 5, -3, and -1. Is that okay? Now recall that if you wanted to take the determinant, you will go like this and like this, but there is a trick. There is a trick. And the trick is this. Repeat this 1 and j, I and j column. Repeat these two columns outside, I and j columns, with the elements -4, 5, and -3. Now, having repeated them, you now cross like this. Now follow me. You will cross from k like this, cross from j in this direction, cross in this direction. Then also cross from I also. And make sure it's a straight line crossing. So you draw 3 lines. Remember, 3 lines. So after drawing 3 lines, you now take the determinants. And this is where you take the determinant for I. So you say A cross B will become for I. This is what I did for I. -4, you know, is the main diagonal minus the other diagonal. So for I, recall you are doing with I. So you go to the I and say -4 times -1 minus then under I again, the other diagonal is 2 by -3. Those are the 2 elements in the other diagonal. Notice it's under I, so I go back this direction. Under I go this first direction, then under I go back in this direction. So this will be plus, do you understand? I go to J. For J, I'll go to the J, 2 by 5, I have 2 by 5, minus, I go to J again, 3, and I go to J, 3 and -1, that is 3 times -1. And then plus again, we have for the K, we go under K, in this direction, we have 3 and -3, 3 times -3, and minus, we go under the same K, and come here, -4 times 5. Just follow me step by step, and I promise you're going to get it really well. So we now have A cross B, therefore, becomes I into bracket -4 times -1, that is 4, minus, this times is -6. You can write it there. Then plus J into bracket 10 minus -3. Then plus K into bracket 3 times this -9 minus -20. All right, so this becomes I, this will be 4 plus 10, minus times minus is plus, that will be 10I, so we have 10I plus 3 plus 10, that is 13, so here we have 13J, then plus K, plus, we have -9 plus 20, that becomes 11, so we have 11K, 11K, and that will be the cross product. And we are told to find the magnitude also, you just square this, the same way we've been doing it, and that will be your answer. So that is how to find the vector product and the scalar product. All right. Now let me just give us another example. Let me give us another example of scalar and vector products. So in this case, we are going to be finding both the scalar product and the vector product. So now, one of the use of this thing is that you must understand first which quantities are vectors and which quantities are scalars. Which quantities are vectors and which quantities are scalars. So if you were told to find, for example, you are given the vector f, we are given this vector, we are given vector f to be equal to 3i minus 4k, and you now have vector d to be 2i plus 2j minus 5k. Okay, so how do you do this? Now, first, know that if you are told to find work done here, if this were representing force and distance, and you're told to find work done, so you must first know if work done is a vector or scalar quantity. And you know that work done is a scalar. So what you will look for is what? F dot D. Do you understand? So what you find is dot product. And how do you do that? This times this, the same way. This times this is what? 6 plus. Now, because there is no J here, so you have to look for J. You have to impute J there. So this thing can be rewritten as 3I plus 0J minus 4K. You see the way I did that? So you can go back. This by this 6. Now this by this 0. Then plus minus 4 times this plus 20. That's 20. So what we have here is 26 units. And in fact, the unit of work done is joules. So you can say 26 joules. And that is your answer for the dot product. Then if you are told to find the angle between them, find the angle between them here. So having found the F dot D, recall that F dot D is equal to the modulus of F times the modulus of D cos phi. All right, so that what is the modulus of F? The modulus of F will be 3 squared, square root of 3 squared, square root of 3 squared, plus square of minus 4. That becomes 9 plus 16, and that becomes root 25, and that is 5. Okay, and for D, the modulus of D, or the magnitude of D, we have the square root of 2 squared, that's 4, plus 2 squared also, which is another 4. 2 squared also, which is another 4. Then plus 5 squared, which is minus 5 squared, which is 25. I'm intentionally not writing them back here. Is that okay? This plus this is 8. 8 plus this is 33. So we have square root of 33. And that will be our answer for the modulus of this. So then to find, okay, we are looking for the angle between them. Find angle between them. Okay, so angle between them is phi, and we said it's cos inverse of F, the dot product, which gave us 26 over the product of the modulus, 5 times root 33. All right, so by the time you work this, you're going to get the cos inverse, and phi will be your final answer. All right, so because there is no calculator with me, I will just, so this will basically be 5 here, 1, 5 here, 5.2. Is that okay? So what you have is cos inverse of 5.2 over root 33. So to show me that you actually saw this video to the end, give the answer to this question in the comment section. And God bless you for staying till the end. Do well to subscribe to the channel and click the bell notification to get notified whenever I drop new content like this. I keep dropping content on here that you use that will be useful to you in your exams, JAMB, WAEC, and all those other exams. God bless you.